figure out where the ratios in 3069 came from. The first part, if you don't want to, you don't have to write it down. It's just because when I don't want to just throw something up there and you're like, how did she get that? Okay. So the first part you don't have to write down. I'm going to just show how you get the ratios. So special right triangle, 30, 60, 90, they come from an equilateral triangle. So try your best to draw an equilateral triangle if you're going to draw this, which is not a right triangle. Can somebody tell me what an equilateral triangle is? Turn and talk to somebody if you know what it is. What's an equilateral triangle mean? Okay, I'm hearing conversation about things being the same. So technically equilateral triangle is all three sides are the same, which also means all three angles are the same. So the angles in a triangle add up to 180. What's 180 divided by 3? 60. So these angles are all 60. Okay, so if I were to take a bisector, it just means it cuts it in half, and draw right down the middle of that triangle, what happens is it's now cut into two of the same triangle. This is where our 30, 60, 90 triangle comes from. Because if I cut that top angle in half, it's now 30. This angle is 90, and this is 60. Okay. So I'm going to redraw this in a second. I'm simply showing where the ratios of sides come from. Now, in order, because I do not want fractions, instead of making this whole piece a 1, I'm going to make this piece 1. And since this piece is half of the whole side, what would this piece be then? 2, because it's twice the length of that. And if I used Pythagorean theorem, let's use Pythagorean theorem to find this piece. We would take 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4. So x squared equals 3. This x is the square root of 3. Okay. So here's what this means for us. If you take the shortest piece in the 30, 60, 90 triangle and you multiply it by 2, that's going to be the hypotenuse, okay? So let's say this was a 5 instead, then the hypotenuse would be 10. What if this was 6? What would the hypotenuse be? 12. If this was 4, this would be 8, and so on. I could go backwards. If this was 20, this would be 10. So the ratio of the shortest piece and the longest piece, which is the hypotenuse, is always 1 to 2 in a 30, 60, 90 triangle. The other piece is not a nice number, but it's the square root of 3. I always in my head remember 1, 2, 3. So I'm going to write, like I did here, I'm going to write the 30, 60, 90 triangle now, okay? So I'm going to put the short piece at the bottom, and we're going to make that piece longer. And then I'm going to draw the hypotenuse here, and I'm going to label the angles. Let's make this top one 30 and this one 60 at the bottom. Okay, so in general, I'm going to call this X. If you know the shortest piece, you would double it to find the hypotenuse. So on the hypotenuse, we're going to put 2x. And the longest piece is just the shortest piece times root 3. So I don't know if you remember, you all took the PSAT and SAT. Most of you did anyways a little bit ago. These diagrams were on that test and that formula sheet. So you don't need to memorize them at this point. I'll show you some ways to memorize them later on that we might use in pre-calculus, but you just need to know what that means or how to use them. Okay, so let's do a little work here. So using this, let's take a look at this triangle right here. And what we have to decide is, what did I give you? Okay. So did I give you the shortest piece, or the longest piece, or the root 3 piece? The root 3 piece, okay? So if I wanted to, this is the x root 3 piece if you like to solve an equation. So if I want to go back and find the shortest piece, I would just divide by root 3. Okay. So x in this case is just 4 divided by root 3. So now that I know the shortest piece, I would multiply by 2 to find the hypotenuse. And 4 root 3 multiplied by 2, 4 over root 3, I should say, is just 8 over root 3. Okay. I put another one up here where I gave you a different piece. I give you the hypotenuse, right? So the hypotenuse is the one that's double the shortest piece. Okay, you guys identify for me, what's the shortest length in the triangle? Which one, x or y? It's y, okay, because it's across from the 30-degree angle. So if this and this are 1 to 2, if I wanted to go back, wouldn't we agree we're going to divide by 2? Okay, so to find y, 2 times y is 2 root 3. I just divide by 2. So y is just the square root of 3. And from the shortest piece, if I wanted to find the longer leg, I just multiply by root 3. So x just equals root 3 times root 3. And root 3 times root 3 is just 3. So in 30, 60, 90 triangles, 45, 45, 90 triangles, you can, because we know those ratios, you can use those ratios to find the other two with only one unknown, whereas the other ones we had to do Pythagorean theorem, we had to have 2 of the pieces. Okay. So that finishes up our 30, 60, 90 triangles. Let's talk about how we find missing pieces in triangles. We all have our calculators, right? So if you have a graphing calculator right now, would you go press the mode button? Because there's 2 modes, and to do what we're doing today, we have to be in the correct mode or you can get the wrong answer. All right, so put my graphing calculator in here just so we're knowing where to go. So the mode key is next to the second key, so you're going to go to that. And if you go down several rows, you see that there's these 2 options, radian or degrees. We haven't even talked about radians yet. Would you make sure your calculator is in the degree mode? On the little calculators, there is a radian and degree mode, but it always defaults to degree, so I think you guys should be fine. This is just like if you have one of the graphing ones. Freddie, did you find it? Yeah. Okay, good. Who else? Yes, did you find it? Okay. Michaela, did you find it? All right, good, because here's the deal. We know sine, cosine, and tangent is a ratio of sides. But your calculator can tell you, if you know the angle measure, what the sine, cosine, and tangent are. And so we're going to use that fact today to find missing pieces in triangles. So I think what I'm going to do, I put a lot of examples on here, is I'm going to show you how to find, one example of how to find missing sides. and then how to find a missing angle, and then we'll do one of the applications. Okay, so first of all, you're going to identify the angle that you're given, okay? 38 degrees. Then you're going to identify the piece that you're given. Remember, we have 3 pieces in a triangle in relationship to the angle. We have the opposite, we have the adjacent, and we have the hypotenuse. What piece is the 10? This is the opposite, correct? Okay. Then you're going to identify the piece that you're trying to find. Is this the adjacent or the hypotenuse? Adjacent. With that information, what you're going to do is you're going to take your ratio and you're going to pick the one that you know. So, using this, which one involves opposite and adjacent? The tangent. So we're going to write a statement. The tangent of the angle, so the tangent of 38, equals the opposite, which is 10, over the adjacent, which is x. Okay, now we're going to solve. If x is on the bottom, the first thing I'm going to do is I'm going to multiply both sides of my equation by x. So now I have x times the tangent of 38 equals 10. How would I solve for x? I need to divide both sides by the tangent of 38. All right, this is where your calculator comes in. On your calculator, you are going to type in 10 divided by the tangent. So the tangent key is in the graphing calculators in this row. Let's see if I have a pink one. In the other calculators, it's kind of the middle row. You're going to use tangent right there. We're going to do 38 and make sure you close your parentheses. Let's see if we all get the same thing. Did you get 12.799 for that? Good. Okay, so let's round that to x is about 12.8. Okay, do you need to see one more of those? I'm happy to do it. I just don't know because you don't. Okay, let's look at number 2. I'm going to give you some thought time in number 2. Okay, that's your angle. I want you to think about what pieces this gives you, okay? Identify that. X is the hypotenuse. 4 is the adjacent. I need to look above for which trig function involves adjacent and hypotenuse. Which one is it? Cosine. So then I write my statement. Cosine of 63 equals adjacent, which is 4, over the hypotenuse, which is x. By the way, sometimes the x is on top and then you just multiply both sides by the number. In both of these cases, it was not. I think that's the hard part of the problem, is the deciding which one and then setting it up. All right, so you multiply both sides by x. To solve for x, then we would divide by cosine of 63. I got 8.8. Okay. That's missing sides. Let's do one of these. So very similar question. We are going to, though, find missing angles. And so I'm going to show you how to do that on your calculator. We're going to set up a statement, though. So here's my x, but this time x is an angle. This time I don't know, but I'm still going to do the sides in relationship to x. Okay, this time I know both of them. What's the 7 in the triangle? What piece is that? Good. And the 4 is the adjacent. Okay. So we're going to use the cosine because cosine involves adjacent over hypotenuse. There are these inverse functions that I'm going to show you. So now I have the cosine of x equals 4 over 7. Okay. So you can't just divide the word cosine. It doesn't work like that. You have to undo the cosine. So the way you undo a cosine are these little -1 keys. They're called inverses. And what these keys do is if you know what the cosine is, it will find the angle for you. I know what the cosine is. The cosine is 4 over 7. So what I do is to find x, I take the cosine inverse, okay, of 4 over 7. So this time for finding angles, you use the inverse functions. Okay, I'll show you on the pink calculator. They're just the second function of the other. So the cosine inverse, I would press the second key, and the cosine key, and then do you see how you have a little cosine -1 that shows up? And then you do 4 over 7. What did I do? I can't see. Cosine inverse. Oh, I didn't do 4 divided by 7. The angle is 55 degrees. Okay, would you guys try number 8? I should have done another one besides cosine. This is cosine inverse again, isn't it? I got 66.8 degrees. Okay, we can call that 67 if you want to round to the nearest degree. Okay, that's where we're going to stop the application.